Okay, so now we're going to convert between polar and rectangular equations. And so we've got our equation here, y equals r sine theta, and x equals r cosine theta. So we're going to use those. So I'm going to replace x or y with r, let's see, r sine theta, and x with r cosine theta. And then I can divide both sides by r cosine theta. And so I would get tangent, because sine over cosine is tangent. My r's just divide out to 1. Here on the left side, everything divides to 1, so I'm just left with tangent theta equals 1. Well, let's see, when does that happen? That happens at pi over 4, or it also happens in quadrant 3 that the output of tangent is positive at, let's see, 5 pi over 4. So those are my two polar equations. And if I was going to graph those, okay, this is just saying it doesn't really matter what r is. Okay, if you come over pi over 4, you could have an r of a half at 1, 7, 2, 5.5, right? It doesn't matter at all. So we're going to have, we could even have our negative r values. So we're going to have all these points along that line where theta is pi over 4. Likewise, if we came 5 pi over 4, they would still lie all on that same line. So those are our two equations in the polar coordinate system. Let's try this next one. So x squared plus r squared equals x squared plus y squared. That is r squared. X squared plus y squared equals r squared, because when we look at what these actually mean, if we have an x and a y, Pythagorean theorem tells me that x squared plus y squared equals r squared. If this is my theta, the adjacent over the hypotenuse, that's my cosine, so that's where this one came from. And my opposite over hypotenuse would be my sine, so it would be y over r. Okay, so this is the other equation that's really useful when we're doing these conversions, because this x squared plus y squared, well, that's just r squared. Okay, and then I can take the square root of both sides, and I get r is equal to 3, or r is equal to negative 3. And then we could graph that. We know just from the rectangular system, this is a circle. It's centered at 0, 0, and it has a radius of 3. Okay, so let me show you how this works. So if I go out 1, 2, 3, for every angle you could give me at pi over 6, at pi over 4, at pi over 3, at pi over 2, anywhere along here, any angle, I'm still always going to come out 3. And likewise, if I went back 1, 2, 3, same thing, any angle, I'm going to always come out 3. Okay, so those are two polar equations, and they both have the same graph. Okay, moving on to our next one. Let's see, if we have x squared plus y squared equals negative 3x. Well, that one's not so easy to graph in a rectangular system. So let's see how hard it would be in the polar. Okay, I know x squared plus y squared is r squared. X is r cosine theta. And then if I go ahead and just divide by r, this would simplify down to r equals negative 3 cosine theta. And because I've done a bunch of exploring and playing around with these, I know that that graph will extend out to negative 3 because it's cosine. It'll open along the horizontal axis. So it'll be, okay, and let's try this one here. This is r squared. Y is the same thing as r sine theta. And then I can divide both sides by r just to simplify it a little bit. And I would get r is equal to 4 sine theta. And from what I know about polar graphing, and again, you can, if you don't know this yet, you can always make an r theta table for yourself and plug in some points. pull out Desmos and just check it on the graphing calculator. But this one, it'll extend along the horizontal axis because it's sine, and it ends there at a positive 4. So it has a diameter of 4. Okay, now if I didn't know polar equations and polar graphing, I would have to complete the square, which isn't impossible. That's fine. We can do that. We would have plus y squared, subtract 4y from both sides. And we could go ahead and complete the square and factor. And so, you know, it's fine. We're not stuck without polar equations, but it was pretty quick and easy doing this way. All right, let's say that we're given this polar equation. So r equals -6 sine theta. So 1, 2, 3, 4, 5, 6. So it's going to open up along the vertical axis. It's going to be a circle. And it would be centered here at -3 with a diameter of -6. Okay, but let's say that we weren't asked to graph it. We were instead asked to come up with its rectangular equation. So let me just show you how you would do this just completely algebraically. Okay, so we know that r squared equals x squared plus y squared. We also know that x is equal to r cosine theta and y is equal to r sine theta. So we're going to set ourselves up to use substitution. But to do that, what I need to do is multiply both sides by r. Okay, so we're just going to multiply by r on both sides. So that would give us r squared is equal to -6 r sine theta. And now we can use substitution. R squared is the same thing as x squared plus y squared. Then we have that r sine theta, that's the same thing as y. Okay, our next step is we're going to set it equal to 0 and complete the square. So I've got, I'm going to add 6y to both sides, and then completing the square. Okay, we take that coefficient, split it in half. So we'd get 6 divided by 2 and square that. That's what we add to both sides. Okay, so we'd add plus 9. And just make sure that we add that to both sides. And then we can factor. So we would have x squared plus y plus 3, quantity squared, is equal to 9. And that would give us the same graph that we just came up with using the polar graph, where we have a radius of 3 and a center at 0, -3. All right, so here, this one is going to, because it's cosine, it opens along the horizontal, and it will end at 3. So it's a circle, and it's centered at 3/2. And the radius would be, let's see, radius is 3/2. Center is at 3/2 and 0. Okay, but let's say, nope, that's not what we want. Instead, we need the rectangular equation. All right, no problem. Okay, use my strategy, multiply both sides by r. Okay, so then I have r squared is equal to 3r cosine theta. Using substitution, we get x squared plus y squared. That's equivalent to r squared. Okay, and then that would be 3 times x, because r cosine theta is equal to x. Now we're going to set this equal to 0, subtract 3x from both sides, and complete the square. So let's see, I need to add, I take that 3, split it in half, and square it. And I would add, so I need to add 9/4 to both sides. 1/4, and then I factor. There we go, and there's our circle centered at 3/2, 0 with a radius of 3/2. Okay, so our steps again, multiply by r, use substitution, then set equal to 0, complete the square, and factor. Okay, now let's see what we can come up with on this next one. If I use that same strategy, just multiply both sides by r, let's see what we come up with. So I'd have r squared. I'm going to distribute my r to both the r sine theta and also to the cosine, so r cosine theta. Now, using substitution, I'd get x squared plus y squared is that subbing in for r squared. R sine theta, that's y. R cosine theta, that's x. Okay, we're going to set it equal to 0, add x to both sides, subtract y from both sides, and now we're ready to complete the square. Okay, so for my x, what I need to do is that coefficient of x is just 1, so I'm going to add 1/2 quantity squared, so it'd be 1/4. That's what I add to both sides to complete my square for the x's. Okay, and now we've got y squared minus y. Okay, so for my y's, it's just a -1. That's the coefficient. Split that in half and square it. So we also have to add, we're going to add a positive 1/4 for y. I'll just scoot that up a little bit. Okay, so then I factor, and I've got x plus 1/2 quantity squared plus y minus 1/2 quantity squared is equal to 1/2. So that one, to be able to figure that one out, I don't know that one in the polar system. I wouldn't be able to just sketch that graph, so being able to rewrite that in the rectangular system, that really does allow me to graph it. All right, so we have a center at -1/2, 1/2, and a radius at square root of 1/2, so at about 0.7. Okay, so that kind of sums up how to go about working with going from polar to rectangular, and these are our steps that really help us out. Multiplying by r, really helpful than using substitution.